Hello. In this video, we will practice a technique often used to help solve quadratic equations. You can solve an equation that contains a perfect square by finding square roots. The simplest of this type of equation has the form a times x squared equals c. Here's an example. First, we will subtract 10 from both sides of the equation. Then divide by 4. Now we have an equation that can be solved by finding the square root of 16. Since both 4 squared and negative 4 squared equal 16, both are solutions to the quadratic and should be checked for accuracy. When a perfect square trinomial is present in an equation, the process is similar. After factoring, we could find the square root of 36. The binomial x plus 3 is equal to 6 and negative 6. When solved, we see our two solutions are 3 and negative 9. Both of these should be checked for accuracy. Fortunately, it is possible to create a square trinomial so that we can solve quadratics using the method from above. First, clear the parentheses and combine like terms so that x squared plus b times x equals c. If necessary, divide by a so that the x squared term has a coefficient of 1. Next, complete the square trinomial by adding half of b squared to both sides of the equation to keep it balanced. This is the same technique that was used in rewriting standard form trinomials into vertex form. Using this method will always create a perfect square trinomial because we are specifically selecting a c value that will follow the pattern. Finally, factor the new quadratic and solve by finding square roots. Here are a few examples. In the first, we already have a perfect square trinomial on the left side of the equation, so we can factor it and solve by finding square roots. Now x minus 15 equals 20 and negative 20. Therefore, x is 35 and x is negative 5. I suggest you check these answers by substituting into the original equation to verify your solutions. In the next example, we need to move terms into the correct form. Subtract 10x and 12 from both sides of the equation. Now, half of b squared is 25. So we should add this to both sides of the equation. After factoring, we can find the square root of 13, which I'll leave in radical form for now. Finally, we should add 5 to both sides of these equations. And we see that x is 5 plus the square root of 13, and x is 5 minus the square root of 13. These answers are exact and precise, but sometimes a decimal is desired. If so, I would go to a calculator at this point and rewrite the answer. I would like you to try this last example on your own, but beware because it will be challenging. It will be necessary to divide by a so that the leading coefficient becomes 1. But in doing so, you'll be left with a fraction on the right side of the equation. Please pause the video now and try this problem on your own, and resume playback shortly to check your work. The decimal equivalent of these answers are as follows. When substituting these into the original equation, we will see a result very close to 0. These answers are correct, but the reason the substitution doesn't result in exactly 0 is because of us rounding our results. This is the reason why we often leave our answers to the quadratic in radical form. Using this method to solve quadratics will be beneficial for you in the future. In fact, a very convenient formula for solving quadratics is derived by using this method. In the meantime, I suggest practicing this technique on quadratic equations we have already solved in this unit. Good luck.